Hello, welcome to Learn from the Case. How are you? In this video, we continue talking about migraine. This is the third video of 5. I am going to talk about the causes of migraine, also about probable triggers of the attacks. Regarding the causes and triggers, there are many theories that are being considered, many of them confirmed to a greater or lesser degree with observational studies and also logic. Others not so confirmed, rather pure speculation but with some good basis that make us continue investigating to learn more. Genetics and inheritance. Migraines have a strong genetic component. The risk of migraine in affected relatives is 3 times greater than in relatives of unaffected subjects, but no hereditary patterns was identified. The genetic basis of migraine is complex and it is not known which loci or genes are involved in the pathogenesis. It might be based on more than one genetic source at different genomic locations that act in conjunction with environmental factors to confer susceptibility and disease characteristics in such individuals. A retrospective study found that 76% of patients report triggers: stress at 80%, hormonal changes by 65% during menstruation, ovulation, and pregnancy, fried meals or deep fried meals, 57%, changes in climate, 53%, excessive or insufficient sleep, 50%, odor, 40%, like perfumes, cologne, petroleum distillate, neck pain in 38%, light exposure, 38%, alcohol intake, 38%, smoking, 36%, sleep late or wake late, 32%, heat, 30%, foods in 27%, aspartame, tyramine, and chocolate have been questioned many times. Exercise, 22%, sexual activity, 5%. Epidemiology. Migraine affects 12% of the population and affects up to 17% of women and 6% of men annually. Among children, it tends to occur more in girls than in boys. Migraine tends to run in families. Its prevalence increases at puberty, but continues to decrease until age 35 to 39 and decreases later in life, especially after menopause. Pathophysiology. Although the pathogenesis is not completely understood, it involves multiple components of the central and peripheral nervous system. It was previously believed that headache was caused by vasodilatation and aura by vasoconstriction, but this theory is no longer tenable. Today, proposals are that several primary neuronal alterations lead to a series of intracranial and extracranial changes that cause migraine. There is activation of trigeminal afferents through the opening of the neuronal pannexin 1 megachannel and the subsequent activation of caspase 1. followed by the release of pro-inflammatory mediators, the activation of NF-κB, nuclear factor kappa B, and the propagation of these inflammatory signals to the fibers of the trigeminal nerve around the basals of the pia mater. This triggers a series of cortical, meningeal, and brainstem events, leading to inflammation in the pain-sensitive meninges and causing headache through central and peripheral mechanism. This pathway may explain the cortical depression, which establishes the aura, and the subsequent prolonged activation of trigeminal nociception, which causes headache. Now I am going to give a screenshot of those proteins that I just mentioned. Transcription factor NF-κB was discovered in the 80s. NF-κB, nuclear factor kappa light chain enhancer of activate B cells, is a protein complex that regulates multiple aspects of innate and adaptive immune functions and serves as a fundamental mediator in inflammatory responses. This NF-κB induces the expression of several pro-inflammatory genes, including those encoding cytokines and chemokines, and is also involved in the regulation of the inflammasome. Furthermore, NF-κB plays a critical role in regulating the survival, activation, and differentiation of innate immune cells and inflammatory T cells. Deregulated activation of NF-κB contributes to the pathogenic processes of various inflammatory diseases. Caspases, discovered in the 90s. Caspases are enzymes that play an important role in maintaining homeostasis, since they catalyze programmed cells death or apoptosis. Currently, about 14 different caspases are known in humans. The name caspase, cysteine aspartate proteases, is due to its activity as a protease with a cysteine in its catalytic side, which attacks residues found after an aspartic acid at its C-terminus, acting at the level of the bound peptide. They are highly evolutionarily conserved proteins. That is to say that although other proteins change over time and evolution, they do not make very significant changes. Human caspases can be divided into groups according to the similarity of their sequences and their biological function. Inflammatory caspases, these are caspases 1, 4, 5, 11, 12, 13, and 14. The structure of caspase 1 has been characterized in depth in this group. Its function is mainly pyroptosis, a form of programmed cell death that occurs upon infection by an intracellular pathogen. Caspases involved in apoptosis. We find two types. Initiators, they are caspases 2, 8, 9, and 10. Their function is to initiate the apoptosis signal. Effectors, they are caspases 3, 6, and 7. Their function consists of massive proteolysis that results in apoptosis. pannexins, discovered 13 to 15 years ago. Pannexins are cell membrane proteins that have been related to the inflammation process in some diseases that affect the central nervous system, such as epilepsy, migraine, and stroke. But not everything about these proteins has to sound so negative, because since some years it has been found that they are also involved in the non-pathological neuronal communication process, since they are specifically located in places in the neurons where the transmission of information occurs. A modulatory role of pannexin 1 has been reported in the activity of hippocampal neurons, an important structure in memory and learning. Anyway, we leave these proteins now. We continue with migraine. It is believed that the cortical depression of Leao since year 1944, a propagated wave of neuronal and glial depolarization that initiates a cascade, causes aura, activates trigeminal afferent, and alters the permeability of the blood-brain barrier through the activation of metalloproteinases of the brain matrix. In migraine without aura, it is suggested that cortical depression may occur in areas where the depolarization is not consciously perceived, such as the cerebellum. And in case you wonder, Aristides Pacheco Leao was Brazilian, from Rio de Janeiro. There is also the role of the hypothalamus, dopamine, and reticular formation that I mentioned in the previous video. And there is debate or speculation about what comes first, hypothalamic signal or neuronal depolarization from the trigeminal. For now, this is like asking which came first, the chicken or the egg. Many neurochemical signals related to the onset of a migraine attack have been observed, but all of them are still not well correlated or understood. Based on vasodilatation, edema, and extravasation of plasma proteins, neurogenic inflammation results from the activation of nociceptors, in this case the trigeminal system. It is associated with the release of substance P, calcitonin gene-related peptide, and neurokinin A, all vasoactive neuropeptides released by stimulation of the trigeminal ganglion. Elevated levels of these neuropeptides have been found in the cerebrospinal fluid of patients with chronic migraine. The following neuropeptides are thought to play a role in pathogenesis: serotonin, released by serotonergic nuclei in the brainstem, RAF nuclei, as I briefly mentioned in the previous video. What is currently considered most likely regarding serotonin is that serotonin levels are low between attacks, because this can lead to a deficiency of the serotonin pain inhibitor system, which helps activate the trigeminal system. It can be mediated by acting directly through the cranial bases in the central pain control pathways and through cortical projections of the serotonergic nuclei of the brainstem. Calcitonin gene-related peptide is abundant in trigeminal ganglion neurons. It is released from peripheral and central nerve terminals and secreted in the trigeminal ganglion. When released from peripheral terminals, it initiates increased nitric oxide synthesis and subsequent sensitization of the trigeminal nerves. It is a strong vasodilator of cerebral and dural vessels, making it a component of neurogenic inflammation, and also mediates the transmission of trigeminal pain from the bases to the central nervous system. Pituitary adenylate cyclase activating polypeptide may also play an important role in mediating migraine attacks because its concentrations rises during attacks and its infusion may trigger migraine in susceptible patients. With this, we end today. If you are tempted, leave me your comments or questions. Thanks for your attention and be very well.